Let's take a look at this problem. We've got f of x is equal to x squared minus 15x plus 50 over x minus 3. Excuse me. The first thing we want to find, it's not 1, it's A, is domain. Well, whenever we have a rational function is a single fraction with variables in the denominator, then to find the domain, you set your denominator equal to 0. So we'll set the x minus 3 equal to 0 and solve. So we get x is equal to 3. Now this is the value we cannot have. If I put 3 up here, 3 minus 3 would give us 0 in denominator. So we put a slash through it. X cannot equal 3. Second thing we want to find is the x-intercept. You always plug 0 into the other variables. So if we're finding the x-intercept, we're going to plug 0 in for y. Remember, f of x is the same as y. So we got 0 is equal to x squared minus 15x plus 50 over x minus 3. Well, whenever you have a single fraction equal to 0 and you're solving it, you set your top part equal to 0. So we've got x squared minus 15x plus 50 equal to 0. This factors using the PSD method. So it factors as x minus 5 times x minus 10. Zero factor property. If you get 0 on one side and you factor the other side, you set each factor equal to 0 and solve. So we got x minus 5 equal to 0 and x minus 10 equal to 0, which gives us 5 and gives us 10. And those will be our x-intercepts. Now our y-intercepts. Again, you always plug 0 into the other variable, so we'll plug 0 in for x. So I got y is equal to 0 squared minus 15 times 0 plus 50 over 0 minus 3, which gives us negative 50 over 3. It's kind of a bizarre number. I wonder what that is. $50 divided by 3. About negative 16.7. Okay, D. Our vertical asymptotes. Now our steps for finding a vertical asymptote is you factor the top, factor the bottom. Well, we've already factored top right here. It factors as x minus 5 times x minus 10. And our bottom can't do anything with. Second step is to cancel. Well, there's nothing I can cancel here. So then third step is set our denominator equal to 0. So we'll set x minus 3 equal to 0 and solve it. And we get x is equal to 3. And that's our vertical asymptote. Now E is our horizontal asymptote. If we take a look at the degree is the largest power of x. Degree of the top is 2, degree of the bottom is 1. If your degree of the top is larger than the bottom, then there is no horizontal asymptote. Slant asymptote. If your degree of the top is exactly 1 larger than the bottom, that's when you have a slant asymptote. Well, that's the case here. Degree of the top is 2, degree of the bottom is 1. Degree of the top is exactly 1 larger. Now how we find a slant asymptote is we use long division. So I'm going to divide x squared minus 15x plus 50 by x minus 3. Now to decide what goes up on top, we look at the first term of each. So I look at the x and I look at the x squared. And you ask yourself, what times x gives you x squared? And that'd be x. Now whatever we put up on top, we multiply by what's out in front. X times x is x squared. X times negative 3 is negative 3x. Now we're going to subtract that line, which means flip signs. So this becomes negative, this becomes positive. X squared minus x squared drops away. Negative 15x plus 3x gives us negative 12x. And then I'll bring down the plus 50. Now again, we look at the first term of each, decide what to put up on top. We ask ourselves what times x gives us negative 12x. And that's negative 12. Whatever we put up on top, we multiply by what's out in front. Negative 12 times x is negative 12x. Negative 12 times negative 3 is 36. We're going to subtract that line, which means flip signs. So this negative 12x becomes positive. This positive 36 becomes negative. Negative 12x plus 12x drops away. 50 minus 36 is 14. Now when what we're dividing by is x minus 3, which has a degree of 1. We came up with 14, which has a degree of 0. When the degree of this is less than what we're dividing by, this is your remainder. And for a slant asymptote, we drop a remainder. So our slant asymptote is going to be y is equal to x minus 12. Okay, so we got f of x is equal to x squared minus 15x plus 50 over x minus 3. We're now ready for, I'm assuming increasing, decreasing. Yeah, increasing, decreasing. So we need to find our derivative. Top part here will be p, and the bottom part will be q. We need p prime. The derivative of x squared minus 15x plus 50 is 2x minus 15. We also need q prime. The derivative of x minus 3 is 1. And our formula is p prime q minus p q prime over q squared. So for our derivative, p prime was 2x minus 15 times q, which was x minus 3, minus p, which was x squared minus 15x plus 50 times q prime, which is 1, all over q squared. So all over x minus 3 squared. Well, let's get rid of these parentheses, combine together like terms. 2x times x is 2x squared. 2x times negative 3 is negative 6x. Negative 15 times x is negative 15x. Negative 15 times negative 3 is 45. Negative out in front of your parentheses flips the sign of everything inside. The 1 doesn't do anything over here. So our positive x squared becomes a negative x squared. Our negative 15x becomes a positive 15x. Our positive 50 becomes a negative 50. All over x minus 3 squared. Now combine together like terms. 2x squared minus x squared is x squared. The negative 15x plus 15x cancels. We've got minus 6x. 45 minus 50 is minus 5. Let me double check that. 2x squared minus x squared is x squared. Negative is negative. Okay, those cancel. Negative 6x. Minus 5. Yeah, it looks right. It doesn't factor. That's what I'm wondering. Looked real close, though. Looked like it would factor. Okay, we got our derivative. Now to find our critical values, you set the top part equal to 0. So I got x squared minus 6x minus 5 equal to 0. And we'll set the bottom part equal to 0. So we got x minus 3 squared is equal to 0. Now the top part, let's use a calculator. Press my y equals clear x squared minus 6x minus 5. You have to have 0 on y2, so down arrow to y2, and if you don't already have it there, put a 0. I had it. But now I'm going to do a second trace, choose intersect. Enter on first curve, enter second curve, looks like negative 1. It's not. We got x is equal to negative 0.7. Let me take it 2 decimal places. Negative 0.74. Let's find our other one. So we'll do second trace, choose intersect, enter our first curve, enter our second curve, and we put 8 in. And we get 6.74. So x equals 6.74. Now in this one, If you got a parentheses to a power equal to 0, you can drop the power and set what's inside a parentheses equal to 0, which then gives us x equals 3. Okay. So we got x is equal to negative 0.74. We got x is equal to 3, and x is equal to 6.74. And build our table of intervals. Clear over here is negative infinity. Clear over here is positive infinity. We want to choose test cases. Something between negative infinity and negative 0.74, like negative 1. Something between negative 0.74 and 3, like 0. Something between 3 and 6.74, like 4. And something greater than 6.74, like 7. Now, we don't have to plug it into everything. Here's our derivative. Notice the bottom part is squared. This is always positive since it's squared, so we don't need to worry about that part. We just need to plug it into the top part and see what our sign is. If I plug in our first interval here, negative 1. Negative 1 squared is 1. Negative 6 times negative 1 is a positive 6. 1 plus 6 is 7 minus 5 is positive, so this is increasing. If I put 0 in here, 0 squared is 0. 6 times 0 is 0. 0 minus 5 is negative, so it's decreasing. If I put 4 in there, 4 squared is 16, minus 4 times 6 is 24. Don't know what it is, but it's negative, so it's decreasing. Double check that. 11, yeah, negative. If I put 7 in there, 7 squared is 49, minus 6 times 7 is 42. 49 minus 42, 7. 7 minus 5 is positive, so it's increasing. It's interesting. Let me double check that. 16, yeah, negative, and then 49 minus 42 is 7 minus 7. Yeah, that's correct. Okay, so it's increasing from negative infinity to negative 0.74. And then it's decreasing from negative 0.74 to 3. And then it's decreasing from 3 to 6.74. And then it's decreasing, or increasing from 6.74 to positive infinity. Normally we might not like decimals, but in business, decimals usually make more sense than some hideous fraction or some radical answer. If I told you it's going to be in 6.74 years, then that makes a lot more sense than if I said some fraction or radical. Okay, next part is mins and maxes. H. Well, our mins and maxes were changes from increasing, decreasing, or vice versa. So this is increasing, changes to decreasing, so this is going to be a max. This changes from decreasing to increasing, this will be a min. And that's on the assumption that they exist at those points, which I don't remember those being excluded. It doesn't exist at 3, but it does exist those two places. So we're going to have a max at negative 0.74, comma, something. And we'll have a min at 6.74, comma, something. Now we want to plug those into our original function. So the easiest way is probably the calculator. So I'll come over here, I'll press, this is also how we're going to graph it. So I'll press y equals, clear. The key to graphing a rational is put parentheses on top, parentheses on the bottom. So parentheses on top, parentheses on the bottom. So we're going to have beginning parentheses, x squared, minus 15x, plus 50, closing parentheses divided by beginning parentheses x minus 3. Closing parentheses. Now your calculator has to be set up correctly. So if you do second window, your independent should say ask. If it doesn't say ask, down arrow to that line, right arrow, put your flashing cursor on ask and press enter one time. Then second mode to exit out. Now if you go to second graph to the table, I'll press delete a couple times, clean out those old numbers. We put a negative 0.74. Negative 0.74, enter. Negative 16.48. Now if we do our min, 6.74. 6.74. We get negative 1.52. And those would be our mins and maxes. Well, let's use this, try to sketch it. Now, I don't got much room here, but we'll try to see what happens. Now, extreme values. Our y-intercept is negative 16.7. And here we got some negative 16 too. So this down here is negative 16, which means this would be negative 8, negative 4, and negative 12. If that's negative 16 down to there, this would be about 16 on the x-axis. This would be 8, and so forth. Okay. Now, domain doesn't matter for right now. Our x-intercept is 5 and 10. 5 and 10. Here would be 4. So 5 would be, I don't know, right there, let's say. 10 would be, let's see, here's 12. Right there. Those are x-intercepts. Okay, our y-intercept is negative 16.7. So it'd be somewhere right here. Our vertical asymptote is at 3. So we got a vertical asymptote here at 3. There we go. And horizontal asymptote is none. Slant asymptote is y is equal to x minus 12. So x minus 12 would look something like that right there. Okay, it's starting to come together. I'm starting to see it. Our max was negative 0.74 and negative 16.48, so negative 7.4 and negative 16.48. Somewhere right here. That's a max. Okay, our min is 6.74 and negative 1.52. I don't know, let's say right there. That's going to be our min. Okay, originally it's increasing up to negative 0.74. Okay, so it's increasing, so it's come up here, it's increasing, hits its max, and then it's going down, which corresponds to this decreasing. So if I were to sketch this, it has to skim this, so it's coming up here, hitting this max point here, going down, crossing the y-axis there, and then skimming it, going down like this. Okay, our other one. From 3 to 6.74, it's decreasing. So it's decreasing, hits this minimum point, starts increasing. So sketch this. It's going to go down like this. It's going to pass through there, hits our minimum point, turns around, crosses the x-axis there, and skims that, going like that. Okay, let's compare that against what the calculator said. If I press graph, see, we get this. We seem to be missing part of our graph. This is a reason why we look at this in calculus, is because the calculus will give you the true picture, not just what your standard display gives you. Anyway, that's our answers.